All right, everybody. I am Dr. Lauren LaRose. Welcome back to the Little Brain Campaign. I am a board-certified child and adolescent psychiatrist and adult psychiatrist, and I have a repeat guest with me today, Towny Robinson from JMAC Pharmaceuticals, and he's going to talk to us about Enlyte, which we talked about a few episodes ago. We're going to kind of go backwards and explain what is Enlyte, what does it do, a little brief refresher on methylation and what that means. And then we're going to dig into a study that's actually being published today. So thank you for being here with us, Towny.
Well, I'm excited to be here again with this news that takes some of the theory that we talked about and converts it into potential clinical practice. I'm Towny Robinson. I'm the CEO at JMAC Pharmaceuticals, the inventor of our product line, and considered an expert on methylation biochemistry, genetics, epigenetics, and psychiatric disorders. So very happy again to be here.
Okay, so tell us again, what is, just like a brief overview of what is methylation, and then what is Enlyte and what does it do?
Methylation is a biochemical pathway inside neurons where endpoint biochemistry is made. That would be endogenous SAMe, which is your universal methyl donor, all the neurotransmitters, which are extremely important, and particularly dopamine and norepinephrine for today's segment, because that's the basis in their deficiency of a lot of problems with ADHD. Glutathione, which is your universal antioxidant or anti-inflammatory, is made there. Actually, DNA and RNA and BH4, which is critical in producing neurotransmitters, and nitric oxide is made there. And it's all made with this unique base product called homocysteine. Homocysteine is a sulfur-bearing amino acid. It's very toxic and it's unstable, but it's the raw material that's methylated that begins the process of all of the production of these others. And on the other side of the equation, folinic acid is a utility folate that's the basis for the production of DNA and RNA base pairs, which are called purines and pyrimidines, and what's called GTP, which is the precursor of BH4 and nitric oxide. So this cycle is so extremely important for normal mental wellness, as well as general wellness. And if it becomes dysfunctional, it's the basis for disease. And in normalizing it, it can be the basis to correlate into clinical responses significantly and remissions, because this is the root risk and vulnerability for a lot of the diseases we're trying to treat.
Right. So basically, methylation is this very complex pathway, this really important pathway. There's a lot of points along the way where people can have mutations, and then something goes wrong in this pathway. And when that happens, their body, their brain is not successfully or sufficiently producing a lot of these neurochemicals that we hear about in mental health and psychiatry. They're really important. And if their body and their brain can't do that, then they're more likely to have mental health symptoms, ADHD, depression, etc.
Yes, that's very well said. But one thing you mentioned is very important, because we tend to key in on one part of methylation. That's the production of methylfolate, which requires the enzyme MTHFR. But this is a multifaceted pathway, and there happens to be single nucleotide polymorphisms or genetic variants for the dysfunction of all these pathways. And in the trial that we'll be talking about, that's what we demonstrated in these children. And fortunately, the product was put together with all that in mind. So the ingredients include these pre-metabolized nutritional coenzymes and cofactors that are designed to circumvent and negate all of these methylation polymorphisms for full, normal, and balanced production of these endpoints. It can be done empirically, or you can test for it. so that you can understand what you're dealing with.
Right. So basically, a lot of people hear about MTHFR mutations. Like that's commonly, I would say, or not uncommonly known. But that's not the only thing that can go wrong in this methylation pathway. You may not have MTHFR mutation, but you might have a mutation somewhere else in the pathway, right?
100%. And in this trial that we'll talk about, there was 42 children in that trial. They came to the trial, which was for ADHD, based on their symptomology or the degree of their disease. And only after that were they tested. So they weren't tested first. So we didn't know what's causing this problem. 41 of 42 had an MTHFR allele.
Wow.
But 65% had one of the other ones. 50% had another one, and we'll probably talk about what those are. And they generally, all of the children had at least 4 of the methylation variant alleles to one degree or another.
Wow.
That was affecting their pathways.
Wow. And these were, how were these children chosen?
They were chosen in a practice. The investigator knew of children that had been coming in that had ADHD.
Okay.
And so they were tested with what's called a Conners parental scale. That's 27 questions of traditional ADHD symptomology, which is impulsivity, attention, and hyperactivity. And then each question, there was a number 0 to 3, and both the investigator, the parent, and the preschool teacher weighed in on that number. You add up those numbers to get a baseline scale. Now, they all had a clinical DSM diagnosis of ADHD, and generally you would probably say they were moderate to moderate severe type patients. And so we had this baseline, and we wanted to see, after 90 days of using one of 2 of our agents, the gummy for the little children 2 to 7, and the gel cap for the older children 8 to 13, or ones that could swallow a pill. We had lots of objectives in doing this. We wanted to get data because the gummy's a new product. We wanted to get monotherapy data for the gel cap because I constantly get asked the question, can this be used as monotherapy? Because primarily it's been used in combination with stimulants to address emotional dysregulation and psychiatric comorbidity that stimulants by themselves don't. So with a clear conscience, I can't just tell somebody, yeah, go out and do that. We recommend that. But now, based on a couple of things, the fact that all the children on the gel cap remitted, and that the literature tells us that 80 to 90% of ADHD is heritable or genetic in nature. But it could be as many as 6,000 areas of variants that conspire to cause one thing. But what we're finding out is that it's primarily involved around these methylation single nucleotide polymorphisms. And that if you address those, like we did in this trial, that you can have clinical wellness. But it kind of proved that you could say the gel cap could be used as monotherapy because of the nature of the disease was genetic, and that the ingredients in that circumvented, those genetic defects to normalize dopamine, norepinephrine, and to ability to have SAMe methylate what's called COMT, catecholamine methyltransferase, which normalizes and balances dopamine and norepinephrine in the prefrontal cortex. There lies your problem, and then there lies your answer. Now, this is a small trial, and it was an open label trial, but it starts us down this road of understanding that there can be other options to address the vulnerability. 80 to 90% root cause, that's a big thing. And I have to say here today that this is a question that psychiatry has never asked. what's wrong?
Yep.
What's wrong?
Mm-hmm.
It's too multifactorial for any of us to understand or know what's wrong. And even, just talking, if it's okay,
Yeah.
the ability to address untoward stressors. One of what people think is a primary cause of psychiatric pathology is untoward stressors, abuses as a child,
Mm-hmm.
and things like this. As a matter of fact, the inability of production of SAMe reduces the ability of your body to process untoward stressors. If you had normal biochemistry, you're probably able to process a
Yep.
good bit of that.
Yep.
What's happening is with this product is its ability to do this work unifies all of what's considered the main causes of psychiatric pathology,
Mm-hmm.
which are genetics, the neurotransmitter theory, hormones, inflammation,
Mm-hmm.
and untoward stressors. They're all unified within the biochemistry inside neurons.
Yep. Yep. I'm going to comment on that real quick because I think in my profession, in psychiatry, for most of our history, we have not really had anything to back up our diagnoses and what we see, right? Like we don't have x-rays. We don't have up until recently, we didn't really have blood tests to tell us what's going on, right? Like we didn't have any kind of physical evidence for a very long time to back up what we were seeing and what diagnosing and treating, right? And so I think unfortunately we've made assumptions that, okay, if I see ADHD in several members of this family, or let's say alcoholism, right? If I see alcoholism in several members of this family, it's mostly modeling and learned behavior, right? Your dad's an alcoholic, so you watch that growing up and you become an alcoholic. And we need to really reframe and rethink this, that this is happening in families because the families share the same DNA, right? They share the same mutations.
Yes.
Okay. So that means the same biochemical processes in their brains and in their bodies are going awry.
Yes.
Right. And that is creating these mental health issues.
Yes.
And learned behavior does, that is a real thing in modeling, but I think way more of it is biological, neurobiological in nature than what we had realized for a long time.
Yes. You're exactly right. It's heritable.
Yes.
But that's what's heritable.
Yes.
It's not the pattern behavior.
Right.
Because that in some families where things are terrible for some siblings, you'll have one that just goes on
Yep.
and becomes an Elon Musk.
Yep.
Of
Even
the
though
world.
they were raised in the same family.
Yeah. What happened here?
Mm-hmm.
And this is a lot of what's going on.
Yep.
Some of the things that we have now are really kind of unknowns. Inflammatory markers are used primarily for arthritis and things like that. But now you have CRP.
Mm-hmm.
There's studies that show with methylfolate extreme reduction of CRP in patients, with psychiatric pathology. And thereby the inflammatory component is high.
Yep.
You have what's called microglial activation. You have mast cell issues.
Yep.
You have histamine. Even in this trial, and I learned this from our investigator because she'd been getting these tests for quite a while, there's 2 genetic SNPs in methylation called DAO and HNMT. And the variants cause increases of histamine in the brain. And that is now known as an exacerbation of symptomology in ADHD kids. And the others, HNMT is histamine N-methyltransferase, which is involved with transferring a methyl group from SAMe to produce this diamine dioxidase, which normalizes histamine in the brain. So we were all the time over the past years hearing people that say, well, I take this and I don't have rhinitis anymore. Or I take this and my asthma's not as bad. Or I take this and my eczema clears up. Well, that's just telling you that this is the gene that they had,
Yep.
the inability to normalize histamine intracellularly across the body.
Mm-hmm.
So there's a lot of breakthroughs, that came out of this little trial that make it very interesting.
Yeah.
And just the fact that the genome was only mapped, the Human Genome Project in 2022. I know I'm getting off the subject here. This is very,
Yeah.
very important. There's 25,000 genes in the human genome,
Mm-hmm.
but there's 3 billion base pairs of DNA. Like, for example, in the MTHFR single nucleotide polymorphism, there's 22,000 base pairs of DNA. And amongst those, you have maybe 14 of those base pairs where the nucleotides have been aberrantly switched. But what the Genome Project said, Eric Green himself in a press conference, is that amongst the 3 billion base pairs of DNA, there's 2 million single nucleotide polymorphisms, and that they account, in his mind, for 60% of the cause of chronic disease in the United States. And that you guys, meaning the medical community and meaning pharma, need to get out there and find ways to deal with that.
Right.
And we've been doing that. And it's actually the form of the way that we're doing it has been identified by HI.
Yeah.
And it's called downstream pathway modulation. So what we're actually doing is we're providing the product that negative genetics can't produce on the other side of their negativity in methylation to provide methylation with the fuel that it needs to make these endpoints.
Right. So it's like we may not be able to change the mutation that you have, that you were born with.
100%.
Right. But we can correct or clean up the damage that mutation has made.
Exactly. And that's in the literature, but nobody's really doing that work. I have to say that we kind of backed into that.
Yeah.
It was never the goal of this product in the first place. But we only knew about MTHFR polymorphism when we started this in 2011. But now we know about the 13, 14, or 15 other, impactful, prevalent SNPs in methylation. And we can circumvent those. As you add all the coenzymes that were needed based on the literature to make these endpoints, they happen to have the ability to circumvent the negative effects of the others. And it's not just metabolic blocks, it's transport and absorption blocks. So you're talking about 3 modalities of relief or remedy there.
Right. Okay, so before we talk about some of these case studies, I wanted to give like a personal example from my practice. I have a patient who's about 12 or 13 now, but I've been treating him for many years. He has autism, he has ADHD, he has been on so many medications. It has been very difficult to treat him. And I don't know why it took me until recently to like have it click and be like, let's try Enlyte.
Right.
So we started it probably about 4 months ago, 3 or 4 months ago. And his mom emailed me earlier this week and said, I have never seen my child look this good. And that was the only change we made. And it was like, wow, like just that little change made such a huge difference in a family that has suffered for so many years. This kid has struggled in school, struggled socially, struggled academically, and, he's finally getting some relief.
We hear that quite a bit, and it's a result of what's going on here. This fellow named Charlie Sargent, he's a psychiatrist in Texas. He's in charge of the Texas Foster Kids program. He started using this about 8 or 9 years ago. And I know I'm going to get emotional telling this story. He called me over there. Most of them are Hispanic. Hispanics have a high incidence of MTHFR polymorphism.
Okay.
Most all the children were at least in and out of 3 to 4 more homes.
Yeah.
And they had parents there waiting to see me, like the ones you're talking about.
Yeah.
And they said, we can't believe this.
Yeah.
That these children are more cooperative, they're thoughtful, they're empathetic, they want to work together for other people. They're able to project their desire to understand other people's thoughts in a family situation. All this pathology in these children, everybody assumed it was personality, but like we said before, it was pathology, and nothing's a panacea. And these are things to different degrees that we have relief. But my personal thought is, and it's even the American Psychiatric Association's thought, is that both with ADHD and depression, their recommendations for MDD, they don't require, but they suggest that adjunctive use of a product like ours, almost exactly the same, with SSRIs or SNRIs, to address this component of the disease process, polymorphisms and biochemistry, that you double remission rates and reduce dropout. And the same thing with stimulants in kids. But now they're even saying as monotherapy, you get your choice. If someone doesn't want this, or a child you're worried about suicidal or violent ideation, and they have depression and things like this, we have data on this that it can work and do this work. So we're very happy that it gives an option for you. And you get to decide why that you want to try this.
Okay, so let's go through some of these cases, because these were really amazing to read about. Okay, let's start with this first one, case 1. Okay, so I'm going to read out the case and then we'll discuss it. All right, so AB is an 11-year-old who presented with psychological testing confirming ADHD, and she had consistently performed below grade level in all subjects, particularly math and reading. Teachers reported focusing issues, inability to complete tasks and assignments, and that many assignments that she completed were simply not turned in. Teachers also noted that exposure to material was not correlated with recall, and she was often described as tuning out during her class. Her Connor score was 45 at the start of therapy. So again, that's a scale that we use to just like aid in diagnosis of ADHD and kind of gives us an idea of like severity of symptoms. Her genetic profile included MTHFR positive status, so she did have a mutation, fast MAO, and slow COMT activity. Okay, so those are other mutations in this pathway, and a moderate reduction in DAO activity. AB, so the child, completed with Enlyte gel cap therapy, taking 1 gel cap daily for 90 days, missing only 1 dose. At the study's conclusion, her teacher reports indicated she was much more attentive in class and has been able to complete most assignments during class time. Her recall of material was improved and reflected in higher grades. Parents were pleased that she would now do homework right away when arriving home. Her Connor score at the end of the study was 22, so going down more than 50%. Started at 45, ended at 22. She remains on Enlyte 5 months post-study and is current in performance with her grade level in all subjects, with report cards noting a confidence that is rebuilt.
A couple of things. A lot of the children had above 55 or above, and some had 40s like this. So what's the difference? The Connor scale points out traditional symptomology, which is attention, hyperactivity, and impulsivity. But most all of these kids, NIH says 80% of children with traditional ADHD symptoms have at least one psychiatric comorbidity. It could be OCD, it could be anxiety, depression, it could be any number of these psychiatric disorders. So those aren't picked up in that scale as a high rate of pathology. And there's a number of those in here. But some of them had the biggest differential results, which all of it really comes together in these children.
Yeah.
So holistically treating them becomes very important.
Yep.
Now, on the genetics here, in the literature, most of the studies, and there are some meta-analysis with regards to MTHFR probability in ADHD, they point out that the A1298C heterozygous has the highest prevalence, which is kind of unusual because it's the least virulent of the whole bunch. You're still producing 80% of your MTHFR, but it's still not enough to prevent, untoward stressors and a whole host of other things, particularly if it's combined with these others. MAO is monoamine oxidase inhibitor regulation in synapses, and it just says that people with this, whether it's the high or low, have high symptomology as related to ADHD. Now, the COMT, there's three main variants there. You probably know what they are. There's the VAL-VAL, the MET-MET, and the heterozygote. The VAL-VAL form means that you're making too much of the enzyme that clears dopamine and norepinephrine from the prefrontal cortex. Traditionally, with folks like you that get these, and they get that, that's their clue to double up on their stimulant. And it works.
Yep.
But we help there. Dopamine is one of these things, I call it the Alice, the three bears, the Goldilocks principle. This one's too much, this one's too little, this one's just right. We're looking for balance here.
Yeah.
And when you add our product, it normalizes SAMe. SAMe methylates COMT, literally attaches itself to it, goes into the prefrontal cortex, and provides methyl groups to change dopamine and norepinephrine to the positive or the negative to keep a balance there. So COMT can always be helped because we normalize dopamine production, and particularly in the MET-MET or the heterozygous forms, you don't have enough.
Right.
So you can use whatever can be made to add to the mix of the imbalance there, along with the addition of the SAMe2. So it's helpful there. And then lastly, this DAO is the one that I was talking about before. And it's what our investigator taught me. And if you were to go online and look and see about this, how does histamine affect ADHD symptomology, there's lots of information there, and from AI too. But the primary way to normalize that is to circumvent this negative SNP, so to speak, single nucleotide polymorphism, for production of what it's supposed to do, diamine dioxidase, which actually neutralizes histamine in neurons and in your brain. You hear about, especially in the integrative community, mast cell degranulation and things like this, or microglial activation, which is very similar, because once microglia, 19% of the neurons in your brain are immune neurons. A lot of people don't know that. And they're at work all the time trying to fix things that are going on bad. But if they get overworked, they produce as much cytokines or pro-inflammatory ingredients than they're trying to fix in the first place. And then if you have high homocysteine because you're not methylating it due to you don't have enough methylfolate, it just becomes a mess. And that's a lot of what's happening with regards to the inflammatory things. So that and all of these things, when this trial comes out, if anybody wants to read it, it gets very detailed as to the symptomology. And parents will hear things here that they recognize within their children.
Right.
And they know if they all can get along or if they can't, and they can't get along because such and such won't let them. And this seems to help in every case like that. Anyway.
And just like to remind people that these children that were entered in the study, y'all didn't know if they had the mutations or not.
We did not know.
So it just goes to show you, if y'all were able to do a study with 1,000 patients one day, most likely a very large percentage of those would have one or another mutation in this path, in the methylation pathway.
Yeah. Here's the thing on that. A big principle in medicine is do no harm.
Right.
Because this is all natural and relatively inexpensive, paid for by Medicaids and insurances in some cases, particularly in Louisiana, why not try it? And we don't talk about it much, but all these kids get vitamins. This can serve as their best vitamin because it's a super vitamin for normal general well-being. And then it helps with compliance and it helps with cost too. So you're, killing a bunch of birds with one stone.
Yeah. It's, it's like if we're already, giving these kids medications that we know have a lot of side effects, right? Not for every kid, but for a lot of kids. Why not try something that's natural that we're seeing now in the research actually can provide significant benefits, for their brain health, for their academic performance, for their social performance, for their personal life, their family life. Why not try?
Yes.
Why not try?
And that brings us to the fact that there was two groups here. There was a gummy group, which we just developed a gummy, and it's the first oral treatment of any kind for children 2 to 6. And a lot of these problems, particularly in autism, emanate out early.
Yeah.
And then you can get this folate where it needs to be, besides the symptomology. We wanted to see if the dosing and the amount of the ingredients in the gummy and whether they like the taste. As a matter of fact, there was a taste test involved, and the gummy was 71% thumbs up, which, that's really good.
Yeah, because, that's probably my number one complaint from kids, whether it's medication or supplements, is the taste.
Yeah. Why don't you do number 2, because that's a 3-year-old.
Yeah, let's do that, and we're gonna. I think that's a good one to close on. Okay, so BC is a 3-year-old male who is described as fully or partially inattentive to instructions from parents and teachers. When he was asked to do routine chores or activities like dressing, brushing teeth, the request was usually met with emotional dysregulation, principally anger outbursts. This is what I see all the time in my practice. If he was unable to remain still if an activity was not of interest and engaging him in continual activity. His Conners 3 score at the start of Enlyte gummy therapy was 55. That is high. His genetic SNPs, so the mutations included MTHFR, very slow MAO enzymatic activity, and very fast COMT activity. BC, the child, complied with Enlyte gummies 75% of the 90 days. That's pretty good for a 3-year-old. At study end, he was described by teachers as now able to follow directions for preschool activities, and his outbursts were no longer an issue. His Connor score at study's end was 27. And I can say, as a parent of a child that was exactly like this at 3 years old and for many years after, having your kid be able to participate in school, not have outbursts, stay in school is, life-changing for the whole family.
Yes.
The whole family.
Yes. So this combative type situation, how do you verbalize that? What do you call that symptom yourself in general?
Like, do you mean the outbursts?
Yeah. Well, defiance, the outburst. It didn't want to do, and that can get worse.
Yeah. Yep.
Especially if you just give in.
Yep.
But if it's pathology, you just have a big problem and a big mess. So that seems to be the hallmark of most of the little kids. Is it just a matter of degree?
Yeah.
To where you say it becomes pathological?
Yeah, and I think, one of the most common things I see in little kids is like this emotional dysregulation. For people coming into my office, emotional dysregulation is so challenging because it's disruptive, and these are the kids that are getting, sent home from school, asked to leave school, asked to leave camps. And so then the parents can't work, because they're constantly going to have to pick up the kid. And, when it's happening at home, it's disruptive to the whole family, right? Like the parents, can't get the dinner cooked, and aren't able to pay attention to the other children because they're having to manage these outbursts. Like emotional dysregulation is so destructive for the whole family.
Yeah. Yeah. I think that's the theme that we're
Yep.
coming across here, and that this helps that, just like the foster kids in the Texas program, and they had better school days.
Yep.
And they stayed in the home.
Yep.
And this is what we're trying to accomplish here.
Yeah.
And a lot of it's genetic, and this fixes that. Just to let you know the results of the study. So there was 38 completers out of the 42, and some only had 50 or 75% compliance, but they still had as good scores. So that just means that these genetic polymorphisms were prohibiting that. And just the little bit that they got, they were able to go. The mean reduction, or the average, in the Conners Parent Rating Scale on onset was 54.7. That was the average of the 38 children, which is moderate ADHD. And at the end of the study, the average was 29.6, which the literature tells you that 29 is the top side of remission. So you have significant response. And for all practical purposes, remission. Like I said, it's a relatively small trial, but the investigator is highly ethical, and I wasn't worried, but I didn't know what to expect, and that's why we sent it there. Was to see, so we can have the confidence to at least promote this to the degree that we are.
Well, this is amazing. How can people find y'all and find Enlyte?
The best way is to go to enlyterx.com. I will, just announce here that we transitioned the form of the ingredients here and are adding folinic acid, 1 milligram, and that has FDA clearance and CMS, and we will have that probably by the end of July, and the Louisiana Medicaid people have already approved it for all plans. So this is going to be really helpful for ASD and ADHD kids and their families to have better lives, to have a higher quality of life. And this also is a prevention as well going forward on a lot of technical levels that I understand, but you just have to believe that. A bad start is indicative of worse occurrences in adolescence and early adulthood. And some of the combination of these polymorphisms can lead to bipolar and schizophrenia. And this can help prevent that. Based on what Dr. Stahl says, not what I'm saying.
So like if we can catch these kids young, treat them young, we have a better chance of preventing some serious negative outcomes later in life.
Yes, ma'am.
Well, thank you so much for being here, Towny.
Yes.
And thanks everybody for listening.
I appreciate the opportunity, and thank you.
All right. Have a good one.
Yes, ma'am.
Thank you for tuning in to this episode of the Little Brain Campaign podcast. If you enjoyed our conversation, give us a follow on your favorite podcast platform so you never miss an episode. Please take a moment to leave a review while you're still thinking about it. It really helps grow the podcast, and I love hearing from our listeners. See you next time.